Hello, everybody, and welcome. Thank you all so much for joining tonight. My name is Nick Koberstein, and I am a math teacher in residence at NumWorks. I joined NumWorks after teaching high school mathematics for the past 9 years, and I'm very excited to be with you all tonight to dig a little deeper into the great features available on the NumWorks graphing calculator. If you joined us or watched our previous webinar introducing the NumWorks graphing calculator, this is a great follow-up to explore some additional features. If you didn't have a chance to be with us before, this is still just a great resource for you. And you can also find that previous webinar on our YouTube channel. We're going to be recording tonight's session, and it will be available online for future reference. So just be sure to subscribe to our YouTube channel so that you can stay up to date on all of our upcoming webinars and tutorials. So here is our agenda for tonight. This session is going to focus on taking a deeper dive into some of the features of the calculator that weren't discussed during the welcome webinar a couple weeks ago. There will be also some time towards the end to answer any questions. And towards the end of the webinar, we'll have some resources and offers, as well as a quick survey. Your feedback is incredibly valuable and would be greatly appreciated. There's also an opportunity on the survey to request a certificate of completion. So if we have any educators out there needing that documentation of attendance. So in addition to being one of the most affordable handheld devices on the market, I do want to mention again this time that we do offer a free online emulator. There's no downloads or registration or licenses or even installation required. You can just hop on to numworks.com/simulator and you'll have a fully working exact copy of the software on your device. It's really the ideal tool for class presentations as well as remote learning, but it's also just a great way to provide access to the device to all of your students. And if you are worried about an internet connection, in addition to that online version, you can download the simulator to your laptop. You can also find it on the app, find the app on your Apple and Android devices. All right, so we're gonna dig into some of the apps and some more of the advanced features. If you have any questions about an app, please don't hesitate to drop a question into the chat. Anna is with us tonight as a moderator, and we'll be happy to answer any of those questions directly. So we're gonna focus today on 3 of the apps, really: the calculation app, the functions app, and the equation app. And we're gonna start with that calculation app. So again, with the calculation app, this is a great place to perform a variety of computations that can include your complex numbers, matrices, trigonometry, combinatorics. You can even evaluate derivatives and integrals, and even do some unit conversion. So I'm gonna just enlarge my calculator here for you, and we're gonna get started. So here I've got my home screen. This is where all of our apps are available. So we're gonna just click OK. Right now we've actually got the calculation app highlighted. So I'm gonna click OK to enter that calculation app. And we're gonna start our deep dive with some matrices. So as discussed in that first session a couple weeks ago, there are 2 ways to create a matrix. The first method is to use the toolbox. So the toolbox key is right here. It's got a toolbox on it. So if we open up the toolbox, we've got a lot of options. And what I'm going to do is navigate down to the menu matrices and vectors. And to go into the menu, you can press OK or the right arrow. And that very first option is a new matrix. So by selecting this option, we will construct our first matrix here. And I'm going to create a 2x4 matrix. So 2 rows, 4 columns. And I'm just going to put in some numbers here using my keypad here at the bottom. And I'll hit the right arrow key to add another number. Notice that when I type in that value, it actually adds another column for me. So I could type in my 1 and 0. I don't have to put any more columns in. These gray boxes are all optional. I could go over and add another one, but I want to do a 2x4. So I'm just going to move down to my second column. And we'll do 1. Now, actually, real quick, notice that turned yellow. That's because these are now required cells. In order to have a complete matrix, I am required to enter those values. So 1, 3, 5, and 1. That'll be my first matrix. So I could click OK or execute, but I'm actually going to go ahead and store this matrix as a letter. So I'm going to store this so I can refer to it later. To store a value, we'll hit the Shift key, And then over here, we've got the arrow key. So we're gonna store this, and I'm gonna use capital letter A. So I'm gonna hit Shift Alpha, which is gonna give me my capital letters, and then the A key. And I'll hit Enter there. So what I've done now is I've put my matrix into a variable. Let's do the other method for creating a matrix. This was using the toolbox. I mentioned there are two methods. The other is to use the shift options of these two keys here, the key with e to the x as well as the natural log. We'll see that we've got our brackets here. So if I hit shift and this bracket, it's going to also open another matrix. So that's a quick way to just directly do it without the toolbox key. I'm going to do another 2x4 matrix. We'll do 4, 8, 0, 3. And for my second row, I'll do 1, 2, 1, 2. Let's clear that one. 6 and 1. And I'm going to store this as capital letter B. All right, so now we can perform some calculations. So the first thing I want to demonstrate is just multiplying a matrix by a scalar. So let's do 2 times matrix A. So I'm going to do 2 times, and then to call matrix A, I can type A directly. So Shift Alpha A to multiply 2 times A. I could have also actually grabbed those stored matrices from our variable key. So let's say that I want to do some multiplication in addition. Let's say I want to do 2 times A again. So 2, and this time I'm going to come up to my variable key here, and that's going to be where I have all of my stored variables. So a matrix is going to be in our expressions, and there we can see both A and B. So that's 2A plus, let's do 4 times B. And so we can quickly do multiplication by a scalar and matrix addition. Let's go ahead and create another matrix. Let's do a 2x2 matrix. This matrix I'm going to store as letter C. So this is going to be 2, 1. Let's do 7, 4. And I'm going to store that as matrix C. So we just talked about matrix addition. We can also do matrix multiplication. So I'm going to multiply matrix C times matrix A. I'm going to use my keyboard to do that. So Shift Alpha C times Shift Alpha A. So there is some matrix multiplication. If I tried to multiply matrices with that don't match dimensions, so that was a 2x2 times a 2x4, so that worked. But if I tried to do a 2x4 times a 2x2, that would not work. Those those dimensions don't match up, so we get an undefined value there. Now you may have noticed that I used that multiplication symbol here when I multiplied C times A. That multiplication is required because without it, I don't know if I'm trying to multiply C times A or if I'm trying to call the variable CA, which could be defined. So we do need to explicitly do multiplication with our matrices because we could have defined a matrix as CA. So that multiplication symbol is required. There are also several matrix operations within the toolbox. So if we go back to the toolbox and we go into matrices and vectors, we can do things with our matrix. So for example, we can transpose a matrix. So we can switch our columns and our rows. If I want to transpose matrix A, we now, instead of having a 2x4, have a 4x2. Our rows have become our columns. We can also find the inverse of a matrix. So go back to the toolbox. Let's head down to matrices and vectors. And this time, I'm going to go into the matrix submenu where I can see several other operations here. So let's find the inverse of matrix C. So I can type it directly or from my variables key, my expressions, we see that C is also there now. So there is inverse of C. We can do some matrix multiplication. Let's actually take that last result. I'm going to go up to the calculation history using the up key. Let's bring that matrix down and let's multiply it by matrix C. And since this is the inverse of C, we should get the identity matrix. All right. Finally, we can use a matrix to solve a system of equations. So I'm going to pull up a system of equations here and use my reduced row echelon form of a matrix to find the solution. So if we go back into the toolbox and we go to matrices and vectors and we go into the matrix menu, that very last option was our reduced row echelon form. So I can grab that function and I'm going to input a new matrix here. And this matrix is going to represent this system of equations. So I need 3 rows and 4 columns where I'm going to put in the coefficients of my variables. So 2 and 5 and 2, as well as the right side of the equation. Again, those gray boxes are all optional. Now I've got yellow boxes. These are required so that the matrix is complete. And for my final row will be my final equation, -6. Oh, -6. Let's talk about that for just a quick second. There is only one minus key on this keyboard. There is not a minus and a negative. Those are the same thing, so there's no need to remember which key to press. We only have one minus key, so no confusion about that. Coefficient of y is 1, coefficient of z is -7, and then -12. Oop, -12. And there we have our solutions here. So x equals 3, y equals -8, and z equals -2. We're going to come back to this system of equation later whenever we look at the equations application. All right, so let's move kind of away from matrices, but still a little bit in the topic because I want to talk about vectors. So vectors are created using a 1-column matrix. So for a 2D vector, you'll use a 2x1 matrix. For a 3D vector, you'll use a 3x1 matrix. Let's create a vector let's create the vector 3, 4. So I'm going to create a new matrix. And that matrix is going to be 3 for x and 4 for y. And I'm going to store that matrix as capital, let's call it V for a vector. The vector menu, so if we go into the toolbox, again, toolbox is the key, is the one with the toolbox on it, and we go down to matrices and vectors. I'm going to go into the vector menu and we see that we have a few vector operations here. So I'm going to find the magnitude of vector v. So there's my magnitude operation. If I go into my variables key, I can go into expressions where I had my matrices before and grab that vector and get the magnitude of 5. Let's also demonstrate doing the dot product. So matrices and vectors, let's go into vectors and let's do the dot product. I'll do the dot product of v and let's add a new vector here. So I'm going to add a new matrix. Again, I'll use the keyboard, so shift bracket, and let's do the vector 6, -1. And so I get my dot product of 14. So that was just a little conversation about matrices and vectors. There were some questions about that last time, so I wanted to spend a little bit of time talking about those two topics. In our last session, we also briefly talked about the complex numbers. So I want to dig a little deeper and look at the additional results of a complex number. But before we do that, we do need to make sure our calculator is in the complex mode. So what I'm going to do is I'm going to hit the home button to return to our main menu. And the settings is actually one of our apps. It's at the very bottom. So I'll navigate down and to the right to open that settings app. And I'm going to change that complex format from real to Cartesian. This will allow us to work with complex numbers. And while I'm in here, I'm also going to go ahead and change the angle measure from degrees to radians for some of the work we're going to do in a little bit. So I'll hit the home button to go back to the main menu. And let's open up that calculation app because I want to talk about some complex numbers. All right, so let's evaluate -9 plus the square root of -32. Once again, there's only one minus key here, so you don't have to use negative this time, just -9, -9, plus the square root, which the square root button is available in our advanced functions part of the keyboard. That's this top half of the keyboard. Let's do the square root of -32. Before we look at the additional results, if you look at the results, you'll see that we have both the reduced form, or the exact form, and this is in simplest radical form automatically, as well as the decimal approximation. And what I'm going to do is I'm going to hit this up key to go up to the calculation history. When a result has additional results, you'll get the ellipsis here at the end. So I'm going to navigate over to that ellipsis and click OK, which is going to open up those additional results. In these additional results, you see that we have a visual of the complex number in the complex plane. So we've got the real axis here, as well as the imaginary. And if we scroll down, we can see that that real and imaginary part are listed for us, as well as some other information, including the absolute value here, and the argument, or the angle that this makes with the positive x-axis. So there are some additional results that can be helpful when you're evaluating things that are complex numbers, that involve complex numbers. So I'm going to hit this back key to get out of the additional results. I'll move back down into the calculation editing bar. We just talked about this advanced functions part of the keyboard where I found the square root. That's also where you'll find the complex number I, and your sine, cosine, and tangent trig functions. In addition, the shift option of sine, cosine, and tangent are the inverse functions, so arcsine, arccosine, and arctangent. So if I were to evaluate the sine of pi over 2, this is another result that will have additional results. So if I move over and open up those additional results, here for a trig operation, we'll get the unit circle, as well as the sine and cosine values for that angle. And if I wanted to do an inverse function or an arc sine, we'd hit shift sine. That abbreviation A sine is the computer programming language for arc sine, A sine. Let's do the arc sine of square root of 3 divided by 2. And we get pi over 3 radians. Additional trig functions can be found in the toolbox. If we navigate down to trigonometry, we'll see that we have the hyperbolic trig functions, as well as some advanced trig functions, including cosecant, secant, and cotangent, and those inverse functions. All right, so let's talk about units. Again, units are a very powerful feature of the NumWorks calculator. And there were some questions last time about how exactly to use units, like what you can use, how you can use units on the calculator. And one way that we can use units is to do unit conversion. So for example, let's say that I wanted to convert 65 degrees Fahrenheit to Celsius. So I'm going to start by entering my value 65, and then using the Toolbox menu, let's open up the Units submenu, where we have all of our different quantities here. And I'm going to open up the temperature submenu and grab that unit degrees Fahrenheit. So I've got 65 degrees Fahrenheit. All of our units will start with an underscore so that they're not confused with a variable that we might have saved as F. So we have 65 underscore, so units degrees Fahrenheit. And what I want to do is I want to convert that into degrees Celsius. Now you may notice that in the toolbox, when you're in units, the very first option says manual conversion from unit A to unit B. And if you click that option, what that's going to do is just bring that arrow down, which we could have done manually. So I could just hit shift and then my x to the y power, which the shift option is the arrow. So that's the same way to get that. And I want to convert this to degrees Celsius. So from units, I'm going to go to temperature and grab degrees Celsius. So this says 65 degrees Fahrenheit. Let's convert that to degrees Celsius. And we get 18.33 repeating degrees Celsius. This would be the same thing we would get if we applied the formula for conversion. So 65 minus 32, and multiply that by 5/9. Does everybody remember that conversion? I had to look it up a little bit ago. So without having to memorize all of your unit conversions, you can use the NumWorks calculator to do those conversions. Let's also talk about area and volume. So if we go into units and we look at area and volume, we'll notice that, for example, for volume, we have all of our imperial results or units like teaspoons and tablespoons and cups. We also have our metric like liters. We don't have things like inches squared or squared feet. And if we look at area, or I guess that was volume, inches cubed or cubic feet. If we look at area, same thing, we've got acres. And that's because we don't need to have a special unit for that because we already have length. So we can just take a length unit and square it or cube it to get our area and our volume. So let's do an example of that. Let's say that I have 1,400 square inches. So I'm going to grab my length unit of inches, and to make it area, I'll do inches squared. And let's convert that to square feet. So I can go into the toolbox and find square feet, but I can also type those units manually. So if I remember what my unit abbreviations are, I can just start with the underscore key, that's shift comma to get underscore, and then I'm going to hit this alpha button. I'll actually hit it twice. That's going to lock my alpha so that I can do both F and T, hit alpha again to unlock it, and then squared. So 1,400 inches squared is 9.72 feet squared. And if instead I wanted to do volume, I could just switch that from squared to cubic units. So if I navigate up, I'm actually going to navigate up and click OK to bring that back down and adjust this. I'm going to call this cubic and cubed. And so we can do volume conversion as well. In that same way, there were some questions about velocity. You'll notice that when we looked through the toolbox and the menu, or the units menu, we didn't have velocity. And that's because there'd be a lot of options if you wanted like miles per hour, or miles per minute, or meters per second. We have all those units separately. So instead of trying to create every possible combination, you can just type in exactly what you want. So let's say we have 500 feet per minute, and we want to convert that to meters per second. We can do that as well. So 500, let's do feet per minute. So let's hit shift and then the underscore. I'm going to lock my alpha to do feet and then just unlock it to divide. And we'll do, oops. I knew that was going to happen. There it is, underscore, minutes. And then we will convert that into meters per second. There we go, meters per second. So just taking advantage of the shift key to get the underscore and the alpha key to get the characters. So 500 feet per minute is equivalent to 2.54 meters per second. All right, so staying with the calculation app just a little bit longer, I want to switch gears a little bit, talk a little bit about some probability. There are some probability operations within the toolbox. So let's say that we are interested in, from a group of 12 people, selecting 5 for a group. That means we can't repeat anybody, but the order doesn't really matter because we're just collecting a group of 5 people. So this is a combination. So if we go into the toolbox, we can find our probability menu, and within combinatorics, we'll find our combinations. So our combinations will be from a group of 12, we're going to pick 5. So from 12, we'll choose 5 and find out that there are 792 ways to do that. Let's say that instead we had 12 plants and we wanted to arrange them maybe in a window display, 5 of them. So this way the order does matter because that arrangement is going to look different depending on which plant goes where. So that's going to be a permutation. So I will go into the toolbox again. Let's head down to probability. And again, within combinatorics, let's find the permutation. And we'll, from 12, permutate 5 of them. And because those 5, if we pick 5 and order does matter, we could rearrange them and it would still look different. So there are many more ways to do this. There's 95,040 ways to permutate 5 plants out of 12. All right, and then lastly, to wrap up the calculation application, let's do a little bit of calculus. So what I'd like to do is pull up in the toolbox the calculus submenu, and we see that there are 4 things that we can do. We can evaluate a derivative, we can evaluate an integral, a sum, and a product. And what I want to do is evaluate the derivative. Let's do the derivative of x squared minus 3. So I'm going to grab x squared minus 3, and let's evaluate this derivative at x equals 4. And we get that that derivative is 8. Let's actually use this same function and use it for the integral. But before I do that, to demonstrate a couple things, let's actually store this expression, this x squared minus 3, into a function. So just like we've been doing with the matrices, I'll use shift and then the x to the y key, which is the arrow. Let's store this into the function. We'll call it f of x. So alpha f parentheses x close parentheses. So now I have a new function defined, f of x, that is equivalent to x squared minus 3. In the calculus menu of the toolbox, let's take the integral. Let's do the integral from 0 to 4. So from 0 to 4 of, and then I could type manually alpha f of x, or just like we had our matrices in our variable key, if we hit variables and we go to functions, we have now stored the function f of x, which we can grab and evaluate the integral of f of x from 0 to 4 and get 9.3333. So in that last example, I chose to store this expression as f of x, and I did that because I want to demonstrate how those stored values, those variables, are accessible across the different apps on the NumWorks calculator. So we're actually going to demonstrate that by moving into the Functions app. So let's talk about the Functions app for just a quick moment. The Functions app is a very powerful app. It's going to allow you to graph functions and polar and parametric curves. You can discover key features of your graph. You can look at a table of values and, like I mentioned, compute derivatives and integrals. So I'm going to hit this home button to go back to my main menu here where I can select all my apps, and I'm going to navigate over to the Functions app. Notice that my function f of x is already available, and that's because we stored f of x in the calculation app, so as a function, so it's going to show up in my Functions app. Let's take a look at the graph of this function. When we first graph a function, we have our auto zoom turned on. The auto zoom was engineered to provide a display that best showcases the interesting characteristics of a graph, and that's going to include your x-intercepts and your extrema. You can adjust the graph. The way you adjust that graph is using this axes menu, so we can navigate up and over to axes. Before I open that, you might notice that I have a little icon here, and that includes a not equal to symbol. And what that means is that our axes are currently not equal. They are not the same scale. And if you look at that, our horizontal axis is going from -8 to 8, and our vertical axis is going from -5-ish to 30. So these are obviously not the same scale. What I can do is I can go and I can open up the axes, and the first option says make the axes equal. And that's going to put them on the same scale, and it's going to do it in a way that you're not going to lose any information. So if I were to hit that, I just hit the back key to look at this again. If I were to hit that, I'm not going to do anything with the vertical axis. What I'm going to do is zoom out the horizontal axis so that I have the same scale as the vertical. If I zoomed in the vertical, then I'm going to lose this information that I currently have. So let's watch what happens. If I go up and over and open that, and I'm going to click OK to make those axes equal. And the vertical axis has not changed. The horizontal axis, though, has zoomed out. So now we're going from about -40 to 40. And if we look, we have a scale that is the same here. So we've got a nice square where 1 to the right is 10, 1 up is 10. So now my axes are equal. If I want to go back to that zoom from before, I can always just turn back on the auto zoom to get that a very good view. You can also manually adjust your axes if neither of those are what you're looking for and you just want to go in and say, I want to control this. I want this to go from -10 to 10. And I want the y axis to go from -20 -22, that's fine, to 50. And confirm, and confirm. There you have a very similar, just because of the option I picked, window. Okay, so we were talking about derivatives and integrals. So let's talk about how we can use the Functions app to find derivatives of a function at a point. So one way to do this is to head into the Calculus menu here. So I'm going to navigate up and over to Calculus and click OK. And the last option on this says derivative, and it's a toggle. So I'm going to toggle on the derivative, and let's go back to the graph to look at it. You'll notice that at the bottom, we have x, f of x, and also f prime of x. And I can use my left and right arrow keys here to move my point. So x is moving up, is moving to the right, and I can see my derivative value at these different points. It looks like right now my step size is about 0.4 as I move to the right. If I want to try to be more precise, if I'm looking for a value specifically, one option I can do is zoom in. So we can zoom in actually just pressing the plus button. And as I zoom in, that step size is going to get smaller. So now my step size is 0.1. My x is going up by 0.1. And I can see the derivative of the function at a point right here. We can also find the derivative of a point. If I want to pick a different point, I can actually just type in a value. So if I want to find it when x equals 4, I'm just going to hit the 4 and enter, and it's going to move my point to x equals 4. One thing you have to be careful about that is if you want a negative value, if you press the minus key, it's actually going to zoom you out, which is great. If you want a negative number, just type the number first, 9, move over, add the negative, there's x equals -9. Of course, you could also, in the Calculus menu, use the Go To option and select your x value. One more way I want to talk about finding the derivative. So we're looking at one derivative, so the derivative of the function at one point. If you want to look at the derivative for multiple points, you can use the table. So if I go up to the Table tab, and I go over to my f of x column and press OK, I can turn on the derivative column, which is going to add a derivative column. So I have the derivative of f at all of these x values listed. I can change the interval of x if I'd like, or type in these x values directly if I'm interested at -9 and -6 and 12, and I can find those derivatives like that. All right, so let's go back to the graph tab, and I'm going to turn back on my regular zoom here. I think there's some questions I'm seeing in the chat about the Functions app, so I'm gonna look at those in just a moment. There's a little bit of a delay with the stream, so I have to take a look at those. I'm hoping that Anna is able to answer those, but we can take a look at those in just a second. Towards the end, I'll go back to any questions and demonstrate some things if we missed them. So I want to talk about integrals. The integral operation is also in the Calculus menu. Instead of navigating up, this toolbox key that we used earlier in the calculation app is dependent on the app that you're in. So at this point, if I were to hit the toolbox, it's actually going to open up that calculus menu. So I'll hit the toolbox key, which opens up that calculus menu we saw before. And I'm going to go into calculate. And towards the bottom, we have the integral option. And the first thing I need to do is select my lower bound. So same function, let's do it from x equals 0 to x equals 4. So the lower bound currently is 0. If I needed it to be something else, I can use my left key or my right key to pick an x value. I can also just type it in directly. So if I want the lower bound to be 0, I can just enter 0, hit enter, and I'm going to go to 4. I am going to hit this right arrow key because I love this visual where I can see the area under the curve. So I want to go from 0 to 4, and I end up with this great view of both the graph with the area between the curve and the x-axis highlighted, shaded. I've got my expression here as well as my numerical answer. So I love this visual for integrals. The calculation app is a way to do it as well, but the function app can also find your integrals. And to finish up the functions app, I just want to talk about a couple of the options of our functions. So I'm going to back out of my integral tool and go back to my functions tab. And you can actually navigate over to the name of your function and hit OK to open up some options of your functions. So this is where you could maybe turn on or off a function. So if I turn it off, maybe I have a function that I don't want to look at. I want to look at some other functions, but I also don't want to delete it because maybe it's a pretty intense function. So I can just turn it off, which would just not have it show up on the graph nor the table. I can also rename my function. So maybe I want it to be consistent with a problem that I'm working on, and that problem, it's called m of x. So I can rename my function. And then we can also look at the plot range. This is just going to define for where this function is viewable. So instead of -infinity to infinity, maybe I only want to plot it from -2 to 5. So if we look at the graph now, I'm just plotting this curve from -2 to 5. And then the other thing that we can do in the options is change the curve type. So instead of Cartesian, maybe I want to do a parametric curve. So I'm actually going to demonstrate that here at the bottom of my screen is a set of parametric equations. So x of t is, let's go ahead and type that in and see what this curve looks like. X of t is 0.3 times t minus 2.5 quantity squared plus 2. And y of t is 1.5 sine of t plus 6. And before I plot that, let's actually define the plot range. This is going to be my t values. So t ranges from 0. I'm actually going to let this go all the way to 10. And let's take a look at that graph. Let me actually turn on auto. And we have a parametrically defined curve. Hitting that right key is going to increase the value of t. So we can see what's happening as t increases. All right, so that is the conclusion for me of the Functions app. I have one more app that I want to chat about, and then we'll look to see if there are any questions that haven't been answered yet in the chat. So I'm going to hit the home screen to go back to the main menu here, and I'm going to navigate over to Equations. So in the Equations app, in the intro webinar a couple weeks ago, we explored how the Equations app can solve equations and system of equations, and at the time I just did 2 equations with 2 unknowns. And I just want to make a comment that you're not limited to 2 equations and 2 unknowns. In fact, that system of equations we looked at with our matrices could be solved with a system of equations in the Equations app. So I'm going to click OK to add an equation. We've got 3 variables here. So I'm going to 3 unknowns. I'm going to do my x plus y plus z equals 0 template. That just saves me from having to use the alpha key a lot to do alpha x, alpha y, alpha z. All I need to do is add my coefficients. So 2x plus 5y plus 2z equals -38. Again, only one minus key here, -38. Hit OK. Let's add another equation. I'll use that same template. Here my coefficients are 3, and I've got a -2y, a -2y, and a 4z. and that is 17 equals 17. And let's add another equation. Notice that my bracket showed up here to represent my system of equations. And we'll do negative 6x plus y minus 7z equals negative 12. And if I move down to solve the system, I have the same solution as before when I did my matrix method. 3 for x, y is negative 8, and z is negative 2. So depending on the context or the content of your lesson, of what you've been working on in class, you could solve this system of equations using the Equations app. You could solve it using matrices. It really depends on sort of what your goal is. And again, this calculator is super powerful, but what's so powerful about it is just how easy it is to use, which allows you to focus those lessons on sort of like what's going on, what do these numbers represent? Not so much do you have to focus on the actual brute force of solving the thing. You can actually answer a lot or ask a lot of interesting questions and have some really fun tasks. Also, just within the Equations app, I do want to mention a couple things like what happens if you have two parallel lines. So what's the calculator going to do if you have two lines that just happen to be parallel? Well, we should have no solution since they never intersect. So let's say that we have x plus y equals 0 and x plus y equals 5. Those are two parallel lines. And yes, the system has no solution. Or let's say they happen to be the same line. So if I had 2x plus 2y equals 10, well, that's the same line as x plus y equals 5. That means we should have infinitely many solutions since it's just one line on top of the other. And yes, there are an infinite number of solutions. All right, so I mentioned a moment ago that what's really great about this calculator is how intuitive it is, how easy it is to use, which allows you to have really great tasks in your class and great questions you can ask. And so just speaking of classroom resources and activities, I do want to mention that, I think my computer's being a little slow here. The screen just, oh, that's what's wrong, sorry. We do have some classroom resources. If you head to numworks.com/educators/activities, you'll find that there are some activities that are sorted by subject. So we have algebra, pre-calculus, calculus, and statistics. If you go to one of them, like statistics, you will have access to some activities. You can view the activity on our website to see some different activities here. You can actually toggle on the solutions here to see what the solutions are for these activities using the NumWorks calculator. And there's some student and teacher PDFs available for you to print or to post on your class website, like Canvas or Moodle or whatever your classroom is using. Additionally, online you'll find some ACT and SAT tutorials. That again is at numworks.com/educators/tutorials. In addition to just some short tutorials about the calculator, I walk through a couple of the practice tests for the ACT and SAT. So I just released recently SAT practice test number 10. So there are 30 questions that you have access to, quick YouTube videos that you can watch or share with your students. And then also online, I just want to point out that you can update your calculator very easily. The NumWorks calculator is highly adaptive. We have updates released regularly, and it's very easy to do. You don't need to download any extra software to update your calculator. You can just log in, plug your calculator into your computer, and get it updated. You can see in this image that I've got some X's under whether or not it's updated. That's a bad sign. What you want to see is that check mark. That means you're good to go. You are updated. And speaking of updates, I mentioned this a couple weeks ago, but version 17 is right around the corner. It is one of our most impressive and fun updates yet. It includes a lot of features that have been asked for. I got a sneak peek here of some of the images of what you can expect with version 17. I'm very excited about it, especially as a statistics teacher. If you take a look at those right images there, we've got some great tools to use in a statistics class. So if you want to be one of the first people to try it out, you can sign up to be a beta tester. You can do that at my.numworks.com/user/beta. This will give you access to be first informed when the beta version is out, as well as when the official public version is out. Before we look at the questions that weren't answered just yet, a couple special offers for all of you listening tonight. We do have some offers available on our website that's going to include a free sample calculator for any math teachers out there that have not already received one. We also have just some general educator discounts and some bulk order discounts. So if you have any questions about that, you can head to our website. There's a contact link there as well, so you can ask some questions. And if you're looking for any trainings on that, if you have some people in your department who are very interested, reach out to us. We would love to do a training with you, a workshop. It could be similar to the content we were going over tonight and a couple weeks ago, but we would do it in a sort of live Zoom session or something where you could ask questions directly. So that would be very exciting. Let us know if you're interested in that. And then I just want to save some time here. Yes, perfect. We got about 15 minutes left, and I just want to open up the floor to questions. I know there are some questions in the chat. I'm going to take a look at those and see if there's anything I can demonstrate. So put those in the chat. We'll answer those directly through the chat, but I'll also show some things on the calculator as I take a look at those. And while I'm checking those out and you're putting them in the chat, if you want, please fill out this survey. Let me know how tonight's session went, what things you're looking for in future sessions, as well as just any other information. If you have ideas about the calculator or just questions or things you want to see later, you can put that in the survey. That's num.works/advanced survey. That's also where you can indicate if you would like a certificate of completion. So there's a little option there for you to select if you'd like that, and we'll get that emailed to you within the next week. So go ahead and type those questions in. I'm going to take a look at them, fill out that survey if you don't mind, and we'll see what the questions are. And if you are not looking for any questions, you can feel free to head out. I thank you so much for coming. I'm just going to take a look to see if there's anything that I would like to look at here. Here's a question from earlier. It's not showing me. A second derivative. Okay, let's see. All right, so it looks like we want to find the second derivative. So yes, so we do not have a specific second derivative operation, but we could find the derivative of a derivative. So if I were to do this and I had, let's go back to my functions tab. Let me remove this and let's just add a new function. Let me do what I had before. Let me do x cubed. Let's do x cubed this time, minus, let's do 6x. So I've got a function here. So one thing that I could do is I could add another function, and that function could be the derivative of f of x. So this one would be pretty quick to do because I could just go into my toolbox and go into calculus, and I could take the derivative. Now here's what I'm going to do. I'm going to take the derivative of f of x. So in my variables, I have my functions, and I can grab f of x. And if I want to graph this, I'm just going to evaluate this at x. So for all x's, let's find the derivative of f of x. So this is a great way to remember that we're really just taking the derivative value of f of x and plotting it for every x. And so if I were to look at the plot of this graph, yes, I've got my cubic function here in blue, that's f of x. I have my quadratic function, the derivative of my cubic function in green. And then if I wanted to find my derivative values, I could go into that first derivative, turn on derivative, and then now g, which is f prime of x, g prime would be f double prime of x, and I can quickly find the second derivative. And if I go into my table, I could also turn on the derivative column of g, which would be f prime, f double prime. So that's the first thing that comes to mind about how I would view my first, second, or my function, derivative, and second derivative. In fact, if I want to view it, that second derivative, then we could, of course, add another function, which is the derivative of g of x, which would be the second derivative of f of x. And then let's take a look at that graph. Oh, that was a close one. I did f of x. It's supposed to be g of x. Let's edit that to g. So yes, I've got my cubic function, my quadratic function, and my linear function. All right, I'll take a look at the chat and see if there's any other questions. If you are heading out, thank you so much for hanging out with us tonight. There's some contact information, my contact information there. So thank you again for coming tonight. If you stick around, I'll try to answer a couple more questions here. If you haven't had a chance to complete that survey, there's the link for that. Looks like I'm caught up on questions, Anna says. So I'll stick around for a few minutes in case there's anything else that comes up. Thank you again for being with us tonight. And just check out our website. We'll put up some more webinars soon. Just subscribe to YouTube and our newsletter, and that's how you can get first access to all that information.